Hi y'all, welcome back. So now after we finalize the mass balance and we know that velocity is a function of x and there's only velocity component in the y direction, we are ready to perform the spicy stuff. And why is the spicy stuff? Well, in part C, let me write down part C, they asked us to find the momentum balance. So now we study the momentum balance in the transverse and spanwise direction. Okay, let's go ahead and see where we can get those momentum balance equation. Okay, so if you control F your textbook for your electronic version, you find it in table 5.10 page 281, or if you use electronic version is page 300 out of 807. Okay, let's do the transverse x direction or the x direction first. So transverse x direction. What's the momentum balance for this direction? You get, if you copy it from the table, you get rho time partial u over partial t plus u times partial u over partial x plus v times partial u over partial y plus w times partial u over partial z equal negative pressure, partial pressure over partial x plus viscosity mu times partial square u over partial x square plus partial square u over partial y square plus partial square of u over partial z square plus rho gx. Okay. Now, can we simplify this equation? Yes, we do. We have to, or things will happen. So let's say, how can we simplify this equation? This is steady state, so the velocity doesn't change through time. So this term cancel out because of steady state. Okay. Let's see the other term. All these right here cancel out because u is 0. So on the partial u is 0. Okay, similarly, since your first derivative is 0, your second derivative is 0 as well. So you can cancel all these out because of u equals 0. Okay, and the gravity effect, rho times gx, can we cancel it out? Yes, we can, because there's no gravity effect in the stream in the transverse direction. So no gravity effect in transverse direction. So gx is 0. Okay, so what do we have left? We have this term left, and it equal to 0. So we say partial p over partial x is equal to 0. Okay, similarly, just like part B, what does it imply? It implies that the pressure is not a function of x. Okay, we keep that in our heart, in our mind, and see what leads us. Okay, similarly, let's do it in the spanwise direction. So let me write there. So span y z direction. Okay, let's see what we have. We have rho times partial z over partial t plus u times partial w over partial x plus v times partial w over partial y plus w times partial w over partial z. By the way, y'all see the trend? So it's always u, v, w, and then the partial of the candidate, so the w. Y'all see what I'm saying? So the trend is like this. So let me make a note here. It's kind of interesting. So it's u times partial of your candidate over over partial x plus v time partial of your candidate over partial y plus w time partial of your candidate. Oh my god, candidate over partial z. Okay, it seems like a curl or a divergence or a gradient operator. I'm not sure, but I'm just saying there's a very interesting trend right there. So in this case, that candidate question mark is w. So what does equal to? Equal to the negative the pressure gradient in the z direction, partial p over partial z, plus mu times the second derivative, so partial squared w over partial x squared plus partial of w over partial y squared plus partial square w over z squared. All this plus rho times chi z, the gravity effect. Okay, what can we do with this equation? Can we simplify it? Yes, we can. The first term go away, like the 2NE1 song. 2NE1 song go away. It's a good song. Very good K-pop song. The reason why this term cancel out because it's steady state. Okay, how about on this term? It is as well because W is 0. Now, how about our viscous force, this partial, the second partial derivative here? It gone as well. Yeah, right? Because W is 0. We had demonstrated that in part A and part B. Now, how about a gravity effect? It gone as well because there is no gravity effect in the span-wise or the z direction. Therefore, chi z is 0. Wonderful. So what term we have left? Yes, we have this term left. So what does it imply? It say partial p over partial z is 0. Okay, so it means that the pressure is not a function of z. Okay. Wonderful. So that's basically conclude our analysis for part C. In the next video, I'll move to part D and see what the problem asks us and see what result we can get. Okay, thank you all for your attention.